Hello and welcome to Buildings of Tomorrow. My name's Jon Lester, and today we are talking about wireless protocols, wireless technology, and all of the different types of protocols that sit within this wireless space. Why is that the case, and what are some of the benefits and some of the applications where we see these technologies best used? I'm really happy and excited to be joined by Michele Remonato today. He is the head of IoT product management at Siemens Smart Infrastructure. Michele, thanks for joining us.
Hi, John. Great to be back.
Hey, great to have you back as well. In our last conversation, we took a little bit of a view around wireless technology from a facility manager, an owner, and operator's perspective, and we talked a little bit about when is it the right time to choose wireless? When is it the right time to choose a more traditional wired technology? And part of that, we talked a lot around making this decision. There's lots of variables that need to be considered when you're choosing a technology. And if you decide to go wireless, there's a lot of decisions you have to make to choose what kind of wireless, because wireless is not one size fits all. As I think you mentioned in that conversation, there's lots of different aspects and technologies that all sit under this umbrella of wireless. So please give us an introduction before we dive into, because we really want to get into some nitty gritty for some of these popular and well-known protocols around wireless, but give us a little bit of context. What is the landscape and why is this the situation?
Yeah, so first of all, we could talk about wireless protocols for 2 days in a row and still be just at the very beginning of it. So let's try to bring some structure into the topic. There are a lot of variables at play, but the first, I think, most relevant variable is the range that you want to cover when you talk about wireless. So do you just want to cover a few hundred meters? Then normally you talk about short range, or do you want to cover a much wider range, for example, kilometers? And then you talk about wide range. So for someone that is just moving the first steps into this world of wireless technologies, it is good to start breaking down the problem into short range and wide range.
And once we've made that decision, what's the next step? Like, what do we do with it once we've got a connection, once we've got a signal, let's call it?
Yeah. So there are additional variables, of course, that come into play, and today we will try to navigate some of them. The first one is energy consumption, which is a very important topic, right? So is the device that is actually connecting to this wireless network battery powered, or is it main powered? How much energy does it consume to perform its functions? So that's one topic. Another topic is what kind of latency? So how fast do you want to collect this data, right? There may be cases where every 15 minutes is fine. There may be cases where you want to do it in a millisecond. Another variable is how much data do you actually want to transmit? So you have the range, you have the battery, and in general, the power consumption, you have the latency, and you have the throughput and how much data you want to consume. So these are some of the main variables at play. And again, it's very easy to get into very deep technological discussions. There are a lot of people passionate about technology. But more from a customer point of view, it's good to start from the end goal. What do you want? What are the problems that you want to solve? And then work backwards towards what is the right technology, right? And so it's good to have different examples of different protocols, different standards that are out there today, and sort of how to navigate them, right? That's how normally we do it, especially if you are just moving the first steps into this world.
Understand. And when we talk about problems and talk about what are the issues that we're trying to solve with this technology, how quickly does that get to what we're trying to do? Whether it's a monitoring, whether it's a controlling, does that also build into this where you talked about how much information is sent, battery life, range, etc.? Is it how we're using the information and what happens at the other end, let's call it, that also helps us or is important for us to consider when we make these decisions?
I think is a very nice question. Actually, I started by talking about the technology, and let's move into talking about the problems. So the first is really, what is the end goal that you want to achieve? Do you want to monitor? Do you want to monitor and control something? And if you want to do it, to which kind of degree of quality do you want to do it? Are milliseconds? Do we talk seconds, or do we talk minutes? There are then also other problems to deal with. Are the devices fixed in a place? So are they fixed, for example, to a wall, or are they moving, right? So these are the kind of problems that you have to look at. And then again, we look, as we discussed in the last session together, whether we're talking about new build, we're talking about retrofit. So this also has an impact on terms of power supply, in terms of what you can actually do in the building. So I normally look at monitoring versus automation. I normally look at, is it a new building? Is it a building that is already constructed and where basically there are limitations? And are the devices fixed in a place, or are they moving around, right? These are some of the problem-centric questions that we normally ask. And then, of course, different technologies have different qualities. Just to mention a few: cybersecurity, standardization, and the wealth of devices available in different ecosystems. And we can talk about that when we deep dive in the different protocols.
Well, let's do it. So thanks for that summary, because I think it's really important, because like every technology, it's been developed to solve a problem. And this is one of the reasons why we have so many different technologies, because we have so many different problems to solve. Right? And some are short range, some are wide range, some are for monitoring, some are for controlling, some are to send large packets of information, some are for just small ones. So all those problems that you just described, all those variables that you just introduced, you translate then into many different technologies. So let's get deep. Let's get deep in this. Let's dive into some of the technologies. And hey, exactly what you mentioned earlier. There's a heap of these. We could talk about wireless and technologies for days. So we're not going to cover everything. That's not the intention or the goal today. But let's pick some of the let's call it the best known ones, the most prolific ones, like you mentioned. It's also an important thing, depending on your application, to know that there are lots of different devices available that help you achieve your ultimate goal. So let's talk about some of those, the ones that we would know the best, the ones that are most important at the top of the list, let's call it. You talked about short range, wide range. Why don't we split it into this? So let's start with the short ranges. In the short range world, one of the ones we hear a lot about is Zigbee. Give us a bit of an insight. What's Zigbee? Where does it work? Where are its benefits? And why is Zigbee as it is?
Yeah. So Zigbee is a standard based technology. And again, I like to use examples. So while we go through the different protocols, I try to focus more on the use cases rather than the deep dive in the technology. I think there is already knowledge and data available online. So Zigbee is extremely popular, has become extremely popular in the space of home automation. Also in commercial buildings, it's quite popular, and even in some industrial applications. It has a quite rich ecosystem of devices that have been developed over time. And it's basically a mesh technology for short range. So it means that the devices can connect between each others. So it provides a quite reliable network because you don't have a single point of failure. And it normally covers a range between few meters to 100 meters or maybe a bit more. And it works quite well and reliably for this kind of use cases. It was started in the early 2000s, and it has grown in adoption because I think of its reliability and also the quite wide range of devices available. So there are a lot of sensors, thermostats, controllers, lights. So there is a rich ecosystem. And it has grown into a standard. So it means it can be adopted across the board from different vendors, different companies. And I think that's also one of the strengths. And maybe also looking a bit at what is challenging with Zigbee, it is challenging that you have to normally build a custom gateway, or anyway, there isn't a very standardized gateway solution. So depending on the end goal, different gateways may be necessary also to connect different devices. So that's one of the challenges. And the other challenges is that, of course, the technology has been around for a while, so there are now even better options, which we can discuss later if time allows, in terms of energy consumption, so the duration of the battery, in terms of cybersecurity, and in terms of, in general, IP-based technologies. So there are more modern options coming up in the market, but still is a very popular double-digit dominance in most of the wireless markets. So it's a very popular solution.
Perfect. Hey, thanks for the explanation. I like that structure. Absolutely. Let's use applications and talk a little bit about the good stuff and some of the challenges for each of these. The next one I wanted to ask you about is one that we know really well, but we probably know it more because of our phones and our headphones and this kind of stuff, and that's Bluetooth. How does Bluetooth fit in this wireless building technology, operational technology space, and where and when does this make sense for us?
Yeah. So Bluetooth is born especially in the consumer space for connectivity for mobile phones and for transferring small chunks of data. And it's also a short-range technology. You can feel it. So if you connect your phone via Bluetooth just to transfer a file with one of your friends, as soon as you walk away from your friend, the transfer will not work after a certain distance. So it was designed for that. It's a short-range technology. But now with the advent of Bluetooth Low Energy and other Bluetooth variants, it can also be used in commercial applications, and especially in smaller spaces like rooms or floors. It can be used to track devices, to do real-time tracking of devices. It works quite well, and I think there are also different solutions already available commercially for commercial buildings. Its clear limitation is really the range, right? But of course, it works quite well for real-time tracking, and it also has a very good latency like Zigbee. And here I also want to introduce the concept of latency. What does it mean, latency? It's a measure, but for the user, what does it mean? Let's assume you are at home, and normally your eye, your perception, when you trigger a command, let's say you turn on the light, is in milliseconds. So let's say you push a button, and you would like that action to have almost immediate loop towards you. So that's why short-range technologies with very low latency are very popular, because they fit very well, especially when there is an end user, right? So Zigbee and also Bluetooth, they have this strength, right? But again, range is weak, and also when we talk about Bluetooth, there is limited amount of data that can actually be transmitted. So it does fit well, but especially for short range and sort of real-time tracking use cases.
Cool. Hey, thanks for that explanation, because it is something that we see more and more in those in let's say the advanced applications, real-time location services, this kind of stuff. Great for these things, but maybe not great for everything, like we talked about with Zigbee. Let's have a little chat about one of the new kids on the block. So maybe something not as established as Bluetooth in our daily lives, not as established from a technology perspective, 20 years odds with Zigbee. Let's talk about Thread, because Thread is somehow something new, but one that is starting to really take hold. What is it, and why is it such an interesting thing for the industry that we're starting to adopt this so clearly?
Yeah. So for the ones that don't know Thread, it is a new mesh technology comparable. There's a lot of features in common with Zigbee. And I hold it back a bit because I was expecting to talk about Thread. And basically, Thread is sort of, I like to think about it as the next generation or the evolution of Zigbee in a way. Some of its features are extremely interesting. For example, energy consumption. So many of these devices are battery powered. That's also something I didn't mention before. So when you look at battery, of course, as a customer, doesn't matter if you are in a commercial customer or a private customer, you would love the battery to last as long as it can. So Thread really focuses on reducing the battery consumption, the energy consumption, which I think is anyway also important in general for all wireless technologies. It also relies on IPv6, which is the latest IP-based communication, and it also has enhanced cybersecurity features. It also has an even more advanced mesh technology, so that it's extremely reliable network. So if you want to do automation, it is it is probably the best in class that you have today. It is getting already traction in the consumer space, especially for homes. But I expect that gradually it will become more and more of a standard. Of course, it takes time. It takes a certain degree of knowledge also from the different industrial players. But I think over time it will become really popular because of its reliability, and also because it's relying on the latest and greatest technologies available. Yeah, and of course there are already devices available, and Siemens is also active in this field.
Understand. And do you see, you mentioned Zigbee is really established in the residential automation market, in the home automation market. Is that because of the technology, and we expect Thread to go in that direction, or has Thread got broader applications because of this cybersecurity, because of this latest technology? Where do we expect this to grow within the industry as it develops?
Yeah, so I think first of all, the success of these technologies is not driven by the technology itself; it's driven by the value, right?
Right.
And I think Zigbee has been successful in creating value and also in scaling the ecosystem. So there are many devices that can connect between each other and solve multiple problems at the same time. So I think one of the key success criteria is how rich is the ecosystem. There is no one player that can provide all the devices that can cover all the use cases, right? And in home automation, I think the success is especially driven by the wide range of disciplines that you can cover, from security cameras, lights, sensors, thermostats, and so on. And I think it's a little bit the same, but now, especially in the commercial space, cybersecurity, energy sustainability, it's even more important. So I expect this value generation to be driven out of Thread. And of course, it's never a single answer. There are multiple reasons why a technology is or not successful. But I would expect this to be very impactful, especially in the commercial space. And you can see already the impact also in the residential space, because there are major players that have also adopted this technology. Yeah.
Perfect. Amazing. Hey, thanks for the insight into Zigbee. We talked about Bluetooth. We talked about Threads. Time flies, so we're having a lot of fun. Let's jump out of the short range world and jump into the wide range world, and here two names that I think we know well. Let's talk about LoRaWAN first. So LoRa, a wireless application. What is this, and what are the characteristics, and where do we see this used?
Yeah. So LoRaWAN is a wide area, low power technology. It means that it can reach kilometers of distance, first of all, and it also consumes very little energy, which means a battery can last for 5 to 10 years, depending on what is the frequency at which the data is picked up. It fits very well for monitoring, and it is now very popular for metering of heat and water. So in general, when you want to collect a measure from a meter or equivalent device, right? So it's very good at collecting that kind of, it's very good for collecting data, but it could also be used for indoor air quality, for example. You don't need to read indoor air quality data every second, probably not even every minute. Every 15 minutes could be good, depending on what is the regulation. So it does actually have quite good use cases, and very strong use cases actually in the monitoring space. And of course, the fact that with one gateway you can cover a wide area, it also it's interesting from a cost and installation point of view because the investment to get started is lower compared to other technologies where you maybe need to have repeaters and more network equipment. So conceptually, it's also simpler. You normally have one gateway, and then you have all the devices around it, and you don't need to have major setup costs beyond that, right? And where it is maybe less interesting is, of course, when you want to start to automate things, or when you want to start to have real-time commands, then it's maybe not the right solution. Again, connecting to our discussion at the beginning, it really depends on what you want to do.
Perfect. No, thanks, because I think LoRaWAN is one that we hear a lot about, especially in this wide range scope. It's really interesting when you talk, you make that differentiation between the operation and also, let's say, the automation versus the monitoring, and that huge difference between sending information not every second, but every 10 minutes, every 15 minutes. That is a big decision to make when you're choosing that technology. Let's jump into the last one for today, and please here correct me if I'm mispronouncing it, but NB-IoT. What is this?
Yeah, so NB-IoT stands for Narrowband IoT, and it's a technology that actually it's a mobile technology. So mobile communication. So it relies on the same network of 4G and in the future of 5G. And it basically can send it ultra wide, so even beyond kilometers. You can basically reach geographically distributed areas. So that's really interesting. And it also, again, is comparable in terms of battery consumption and reach to LoRaWAN. Of course, the reach is even wider because it has the same reach pretty much of 4G. And it's also a technology which is meant to mainly monitor. And here the idea is really to go into low-cost monitoring. So it should be extremely economical to collect data from devices. It is used, for example, in China for even residential meters. So it's already becoming quite popular. Pretty much every high-rise building have this kind of devices. And the main advantage is really the battery consumption. Of course, you need to rely on a mobile network, which means there is also a telecommunication provider in the game, right? Which is not true for the previous technologies because they could all run in a private network.
Right.
That's a bit different. The previous ones, you could set up a private network and unlicensed frequencies. Here, you need to rely on a frequency provided by a mobile operator. And in terms of what is not so strong for NB-IoT is that it is a technology that was designed for a device that is fixed in a place.
Right.
So I mentioned earlier with Bluetooth is possible to track devices that are moving. This is definitely not a strength of NB-IoT. The device should normally reside in the same place pretty much for forever, or being moved only a few times. And so basically, that's again, NB-IoT is also very good for monitoring, and I would say extremely low cost use cases to get started. Yeah.
Perfect. Hey, Michele, thanks so much. I know we've only scratched the surface, but we just covered a lot of information about these different technologies, but importantly, the applications and the reasons behind the differences, because there is a good reason behind them, and good decisions to be made about what to use where and when. So thanks so much. Always a pleasure. Great to have a chat. Thanks for joining us and sharing your expertise today.
Thank you, John, for having me.
It's an absolute pleasure, and a big thank you out to everyone also who is listening to us, watching us. Remember to like, share, comment, subscribe to us wherever you're watching or listening to this episode as well, and keep your eyes out every week or so for a new topic and more conversations, hopefully in the future with Michele around wireless technology and some of the new technologies and features and functions that we see in the buildings of the future. So thank you, and we'll see you again soon.
Bye. Thank you.